The idea that AI could make all discoveries by itself feels tempting, but misleading. At its core, AI is a pattern finder, a law seeker in oceans of data. If the patterns are present in the measurements, AI can reveal them faster than any human. But if the data do not exist, if our instruments cannot see, cannot probe, cannot reach, then AI has nothing to analyze. In that sense, discovery is not bottlenecked by algorithms, but by the reach of our experimental eyes and ears. Doesn't this mean that the true frontier of science lies not in silicon brains, but in the lenses, detectors, and machines that feed them? History bears this out. The telescope gave Galileo not just a clear sky, but moons of Jupiter, phases of Venus, and proof that Earth was not the center. The microscope opened up an entire universe of microbes invisible before. The particle accelerator shattered matter until quarks and the Higgs boson revealed themselves. In each case, the instrument expanded the domain of the observable. Only then could human or machine intellect distill laws. Without those devices, even the sharpest mind, or the most advanced AI, would have stared into the dark, finding nothing to model. Could it be that scientific revolutions are really revolutions in instrumentation? Today, our limitations are stark. Even the best cryo-electron microscopes cannot show the ultra-fast quantum choreography inside proteins. Gravitational wave detectors, exquisitely sensitive, still miss ripples smaller than neutron star collisions. To probe quantum gravity directly would require energies far beyond anything we can build. Our instruments define a sandbox, and AI cannot step beyond its walls. The paradox is that we imagine AI is limitless, yet its vision is shackled to our hardware, and yet there's a twist. AI is starting to help design the very tools that constrain it. Adaptive optics, controlled by AI, sharpen telescopic images blurred by Earth's atmosphere. Neural networks guide electron microscopes to zoom in only where rare structures hide. Self-driving labs reconfigure experiments in real time, turning weeks of trial and error into hours. In this sense, AI is both prisoner and liberator, bound by instruments, but also shaping their evolution. Isn't it striking that the same algorithms limited by data may be the key to building machines that expand what data exist? The haunting question, then, is not whether AI will replace scientists, but whether scientists will give AI instruments worthy of its capacity. If tomorrow we had sensors to watch quantum coherence flicker inside enzymes, AI could expose a new biology. If we built gravitational detectors sensitive enough, AI might reveal physics beyond Einstein. The destiny of discovery may rest not in silicon minds alone, but in the symbiosis between minds, machines, and the tools that open nature's hidden rooms. Artificial intelligence itself is not the primary bottleneck in discovery. Modern AI can already analyze vast datasets, detect subtle correlations, and even suggest new hypotheses. However, if the data does not exist because our instruments cannot measure a phenomenon, AI has nothing to work with. The true constraint lies in the precision, sensitivity, and scope of the scientific tools humans build. AI is like a powerful brain without eyes. Instruments are what give it sight. AI cannot detect quantum gravitational effects because no detector sensitive enough to capture Planck-scale physics exists. It is like hiring a world-class translator but giving them a book with missing pages. Brilliance is useless without content to translate. Throughout history, transformative discoveries came after new tools were invented. Galileo's telescope revealed moons of Jupiter and shifted our understanding of the cosmos. Hooke's microscope exposed cells and microbes, changing biology forever. Particle accelerators unlocked the subatomic world, from quarks to the Higgs boson. These breakthroughs did not arise from more powerful mathematics alone, but from widening the observational window. Tools opened worlds. Theories followed. The Hubble Space Telescope revolutionized cosmology by revealing the accelerated expansion of the universe. It is like turning on a light in a dark room. Suddenly, objects hidden all along become visible. Today's scientific boundaries are shaped by the ceilings of our technology. Electron microscopes can resolve atoms but not capture ultra-fast quantum vibrations in living cells. Gravitational wave detectors, like LIGO, can sense cosmic mergers, but not subtler distortions from quantum gravity. Biological sequencing maps genomes rapidly, but struggles with the 3D dynamics of proteins in vivo. These blind spots define where discoveries stall, no matter how powerful our analysis. We know quantum biology might play a role in photosynthesis, but lack instruments to image coherence directly inside living plants. It is like listening to a symphony through a wall. You sense patterns, but cannot distinguish the instruments. Another bottleneck is experimental throughput. Many chemical, material, or biological tests remain slow, expensive, and low yield. AI thrives on massive datasets, yet entire fields provide only fragmented information. Without scalable, automated ways to generate experiments, AI cannot perform its full potential. This mismatch between data-hungry algorithms and data-poor domains slows progress. Drug discovery still relies on years of trial and error lab work, despite AI models predicting promising molecules. It is like having a supercomputer ready to learn languages, but only feeding it 10 words per day. Paradoxically, AI is also helping improve the very instruments that limit it. Adaptive optics and telescopes now use AI to correct distortions in real time. Scanning electron microscopes employ AI-driven feedback to zoom in on rare structures efficiently. Self-driven labs use robotics and machine learning to design, run, and refine experiments autonomously. The line between tool and analyst is beginning to blur as AI becomes part of the measurement process itself. Google DeepMind's AlphaFold solved protein structures, but only after integrating experimental data from cryo, EM, and X-ray crystallography. It is like a driver who not only reads road signs, but also helps repair and redesign the roads. Even the most advanced AI models depend on grounded data. Simulations and extrapolations may hint at possibilities, but without measurement, they remain speculation. Reality must constrain imagination. New laws of nature cannot be confirmed without physical observation, regardless of AI predictions. Instruments act as the arbiters of truth in science. Einstein predicted gravitational waves in 1916, but the discovery required LIGO detectors nearly a century later. It is like a brilliant chess player imagining a win, but needing to play the actual game to prove it. The future lies in coevolution of AI and instrumentation. AI will design better sensors, correct experimental noise, and even run experiments adaptively. In return, new tools will provide richer, faster, higher dimensional data for AI to interpret. Together, they will close loops that humans alone could not. The bottleneck is not one or the other, but the integration of both. AI-optimized nanophotonic sensors are being built to detect single molecules with unprecedented sensitivity. It is like pairing a brilliant chef with a kitchen that evolves new utensils on demand. Ultimately, discoveries are limited less by the intelligence of analysis than by the reach of perception. AI can already handle analysis at scales humans cannot imagine, but perception requires instrumentation. Our next revolutions in science will come when AI-driven design and human ingenuity create instruments that reach deeper, into cells, into quantum fields, into space-time itself. Discovery is therefore bounded by the material frontier of measurement. If we built microscopes that could image quantum coherence in enzymes, AI could immediately uncover new laws of biology. It is like an artist with infinite talent who can only paint with the brushes they are given. The paradox is that AI seems limitless in computation and pattern recognition, yet it remains constrained by human-built instruments. No matter how advanced algorithms become, they can only work with what sensors record. Thus, AI may accelerate discoveries exponentially, but only within the window of the observable. Expanding that window remains humanity's task, to build the telescopes, microscopes, detectors, and accelerators that let AI see farther. AI is a super analyst, but discovery is still gated by engineering. AI cannot yet discover dark matter particles because detectors sensitive enough to capture their interactions remain beyond reach. It is like having the world's best detective locked in a dark room. Until we build windows, the mysteries outside remain invisible.